If you are going to write JAMB this year, drop whatever you are doing and listen to me carefully as I'm going to expose 30 tricks that will help you answer JAMB questions easily. Now, these tricks were drawn from frequently repeated questions that have been observed over the years. Now, the first trick is that JAMB will ask you a question about the time it will take an object that you throw up to reach the maximum height. Let's say you throw a ball up. What is the time it will require for the ball to reach the maximum height before it falls? This is a frequently repeated question and it is very simple to answer. Now, before JAMB will ask you to calculate the time it will take the object to go up, in the question, they are going to give you the velocity of that object, the initial velocity, which is represented by U in this formula. T represents time, while G, they may or may not give you G. You should know that it's a constant, that is force of gravity. So if it is not given, use 10 meters per second square. This question is very simple to answer, but many people miss it in JAMB. Now, if JAMB did not ask you the time it will take the object to reach the maximum height, they will ask you what is the total time of flight. Now, understand this. If it takes the object 5 minutes to go up, then it will take it 5 minutes to come down. The two times are the same. So if you know the time for it to go up, then you will know the time for it to come down. Now, this is a trick they use sometimes. Instead of them to ask you the time to go up, they will say, no, let's ask them the total time. So it is left for you now to calculate the time it will take the object to go up. Then you do times 2 of it. Let's quickly look at a very good example to substantiate this. Look at this example. An object is thrown upward with an initial velocity of 25 meters per second. Calculate A, time to reach the maximum height, B, total time of flight. Do you see this? Now, expect this kind of questions. I try to bring out these tricks after a lot of research on how JAMB frame their questions and the areas they ask their question. So pay attention. They are just 30 tricks and I'm going to cover them. I'm not going to be very slow. I'll be very fast. So please don't be distracted and follow me carefully. Now, so like I've already said in the previous formula, A asks us to calculate the time of flight, which means the time to reach the maximum height. So we are going to use time to go up, which is U over G. That's the initial velocity over force of gravity. That's 30 meters per second. And that will give us 2.5 seconds. That is to say, the time it will take this object to reach the maximum height is 2.5 seconds. Now, B, what is the total time of flight? So the total time of flight, since it takes it 2.5 seconds to go up, definitely it will take it 2.5 seconds to come down, giving 2.5 seconds times 2, which is 5 seconds. Now, let's go to the second trick. Now, the second trick is that, remember, all the questions we have been answering are about time. Now, they might ask you a question on maximum height. JAMB might ask you, okay, now, not time, calculate the height it will reach. Now, to calculate the height it will reach, they will give you the initial velocity. They may not give you G. G remains constant. So here is the formula you are going to use. H is equal to U square all over 2G. By now, I believe you know what H mean and what U mean and what our G stands for. So in each case, you'll be given initial velocity. You may or may not be given G. So always know that G is always 10 meters per second square, except if they give you 9.8. Sometimes they give. So if they give you 9.8, use it. Alternatively, you can use H is equals to half GT square once you know the time. If they give you time, because they may not give you initial velocity, but they might give you time. So if it is time they give you, use H is equal to half GT square. Very, very simple. So if they give you time, know what to use. If they give you velocity, know what to use. Please, as I'm treating this question, take them very seriously if you are preparing for JAMB. Now let's go to the third trick. The third trick comes under projectile. All these are now under motion. I hope you are noting all these things. Now under motion, there is a common question they ask under projectile. What is the best angle to achieve a maximum range? This is a very, very popular question. What is the best angle for maximum range? So the best angle for maximum range is 45 degrees. It is 45 degrees. Never forget this. Please, I beg you. I know why I'm saying this. So if JAMB asks you what is the maximum range, what is the range to reach the maximum, what's the angle to reach the maximum range? What's your answer again? 45 degrees. So I have put an image here just to make it solidify in your brain. Look at 3 different projectiles. Let's assume that it is stones that have been thrown and they follow this pattern. Now, first stone, which is the one at the top, the first line there, is 60 degree. Do you see where the stone fell? It fell at 0.87 meters. Now look at stone 2. Stone 2 follow 45 degrees Celsius angle. Do you see where it stops? It stops at 1.0 meters. Now look at stone 3, thrown at 30 degrees angle. And look at where it stopped also at 0.8 meters. So now of the 3 stones, which one covered the maximum range? Is stone 2, which was thrown at 45 degrees angle. So this is what I am trying to explain, please. If the angle is big, the range will be small. It will not cover a large distance. But if the angle is at 45 degrees, it will cover the largest distance. I hope this is very clear. Still under motion, remember they ask a lot of questions under motion. You need to master these formulas that I'm giving you now. Now, at maximum height of a projectile, there are some questions JAMB would ask you. 1, they might ask you vertical velocity. 2, they might ask you horizontal velocity. They might ask you also about minimum, the K kinetic energy, whether it is minimum, it is high, or where it is minimum. Now, when an object attains the maximum height in projectile, the vertical velocity is always 0. What does this mean? If you throw an object and it reaches its highest position, it seems to stop moving at a point in time before it starts coming down. So at that point where it reaches its maximum height and it seems as if it has stopped moving before it starts coming down, the velocity is usually 0. That is to say, as though it has stopped moving vertically, because it's not going higher up again. It's not going higher up again. It is trying to now find its way down. So the vertical velocity is 0. The horizontal velocity, you will use u cos theta. U cos theta, that's the initial velocity cos the angle it is moving. Very important. Very important. Now, and at the maximum height of the projectile, kinetic energy is usually minimum. You know kinetic energy, an energy an object possesses by virtue of its motion. I hope you remember that. And remember, at the maximum height, it's as though it has stopped moving. So kinetic energy will be very small there because the motion is as though it has stopped moving itself. The kinetic energy will be minimum there, while the potential energy will be higher there. I just hope that my explanations are very clear. Take these tricks very serious, I beg you. Let's go to the next trick. The next trick now is under wave. Now we have left motion. Now under wave, you need to know this almighty formula for wave. Please, I beg you. Now, wave speed equation. We have wave speed. If you want to calculate the speed of a wave, you are going to use this formula. V is equal to F lambda. V is speed, F is frequency, lambda stands for wavelength. Please know this. They would always give you this. They will give you and ask you to calculate one. And they may ask you to calculate wavelength. I hope you will know how to make lambda the subject of formula if they give you V and F. You also know how to make F the subject of formula if they give you lambda and V. Okay. With that, now, there are two things you need to understand. Please, 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 please. The speed of sound in air is constant, provided that temperature is constant and other factors. And that speed is 340 meters per second. That's the speed of sound in air. The speed of light is 3 times 10 raised to power 8 meters per second. These constants are very, 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 very important. I would beg you to know them. So write this formula out if you need to under waves and put it as the formulas you must master. The goal is for you to be able to answer physics questions as swift as possible. Now, still under wave, we talk about the closed pipes and the open pipes. So the closed pipes have only odd harmonics. They don't have 2, they don't have 4, they don't have 6. They only have 1, 3, 5, and so on. If you observe here, our L is equal to lambda over 4, 3 lambda over 4, or 5 lambda over 4. I hope you are seeing that. So in case you are asked to calculate first harmonic for closed pipes, you are going to use the first formula, lambda over 4. Simple. If they say calculate the second harmonics, you are going to use, the third harmonics, you are going to use 3 lambda over 4. They don't usually have even harmonics. They have odd harmonics for closed pipes. But open pipes have both even and odd harmonics. I hope this is very clear. So a closed pipe produces only odd harmonics. I've said this before. Flute, for example, is an open pipe, while a bottle is a closed pipe. Yes, flute, air has where it enters and air has where it goes out. That's an open pipe. But bottle, one end is covered, one end is open. That's an example of a closed pipe. I don't need to. Okay, for open pipe, I've already explained this, so I won't take much time. I say for open pipes, they have both odd and even harmonics. So you can see from the formula, we have lambda over 2. We have 2 lambda. That's supposed to have been 2 lambda, but 2 will cancel 2, so we have only lambda. 3 lambda over 2, and so on and so forth. Never forget, JAMB will ask this either in objectives, of course. The difference between all open pipes and closed pipes. Know that open pipes have all harmonics, both even and odd, but closed pipes have only odd harmonics. And know these simple formulas in case they ask you to calculate first, second, or third harmonics. Okay, we say goodbye to waves and come to resistors in parallel. We are also going to look at resistors in series. Now, this is the formula to calculate the total resistance for resistors in parallel. R is equals to R1 times R2 all over R1 plus R2. Write this formula out now. Why I'm giving you these tricks is so that you will be well prepared, well equipped to be able to answer questions swiftly. So once you see a question and it's talking about resistors, and once they say parallel resistors, you know what to do. So, example, if a resistor of 6 ohms is connected with another resistor of 3 ohms in parallel, all you need to do is to assume resistor 1 is the 6 ohms and resistor 2 is the 3 ohms. So just substitute your 2 and your 6 and 3 in the formula, calculate, and get your answer. As simple as that. For equal resistors, just divide by n. If the resistors are 6, for example, so just divide by the number of resistors, which is 2. For example, let's say 4 resistors in parallel, and each of the 4 is 8 ohms. So it will just be 8 over 4. I hope you get that. It's just be 8 over 4. Okay, I'm going to share this PowerPoint. Please remind me to share it in the group. If you are just coming across my video for the first time, chat me in the comment section. I will share my number so that you chat me through WhatsApp and I will share it with you. Thank you. Now we come to power, still under electricity. How do you calculate power? Very simple. And know that JAMB will definitely ask you a question under this. How do I know? Every year JAMB asks question under power. They will either give you the power, the current and ask you to calculate voltage, or they will give you current and resistance and ask you to calculate power, or they give you voltage, power, and ask you to calculate resistance. So copy this formula now and keep with you. Now, what does this formula mean? It means the formula to calculate power is equal to IV. That is, if you are given I and V, what does I stand for? Current. What does V stand for? Voltage. So if you are given voltage and current are asked to calculate power, just multiply them. Now, what if they did not give you voltage, but they give you current and resistance? Then use the second formula. That is, P is equal to I square R. Now, what if they did not give you current, but they give voltage and resistance? Then use the third formula. So to use the third formula, your formula will now become P is equal to V square over R. See the formulas here given under in this white writing. So we have three formulas. As you are seeing that place, we have three formulas there. Please, I beg you, master this formula. They might either give you power, current, and ask you to calculate voltage, or they might give you voltage and power, ask you to calculate current, or they may give you current and power and ask you to calculate voltage. Any of this, you must see this question, so prepare for it. I hope my explanation is clear. Here we come to trick 10. Trick 10 comes from the capacitors. We've talked about resistors in parallel. Now we have capacitors in parallel and in series. So if capacitors are in parallel, how do you calculate the total capacitance? For parallel, you are just going to add directly. Capacitance of first capacitor plus capacitance of second capacitor plus capacitance of third capacitor in that order, if they are parallel. I'm going to show you which capacitors are referred to as parallel or series, because they might give them to you in form of images. But if they are in series, you are going to say 1 over C is equal to 1 over capacitance of the first capacitor plus 1 over capacitance of the second capacitor plus 1 over capacitance of the third capacitor if they are up to 3. And so on and so forth. So capacitors in parallel add directly, like resistors in series. Now, the two are opposite. The way you treat capacitors in parallel, that's how you would treat resistors in series now. They are opposite. Resistors in series add directly. Capacitors in parallel add directly. But capacitors in series add the reciprocal. Resistors in parallel add the reciprocal. I hope this is clear, because capacitors in parallel are not treated the same thing as resistors in parallel. They are treated opposite. That's exactly what I'm trying to explain. Please, if this explanation is not clear, please just chat me in the comment section. Let me explain it clearly, because we must answer question here. You must answer question. Every year question comes from this place. So JAMB may even tell you that instead of them to ask you to calculate question, they might say, capacitors in series are usually calculated as resistors in A parallel, B series, C opposite, D closed, and ask you to choose the answer. So I want you never to forget that the way you treat capacitors in parallel, that's how you treat resistors in series. While the way you treat capacitors in series, that's the way you treat resistors in parallel, that is adding reciprocals. I hope this is clear. Can you remember? So capacitors and resistors behave opposite. Okay, so this is what I mean. This is what I mean now. Look at the capacitors in series. Do you see it? Capacitors in series. Forget about this big image. Go to those two. So if they are in series, they are like this from up down. That's in series. In parallel, they are like this. So please know, because sometimes they may not even tell you they are in parallel or they are in series. For example, they will just give you this image and say calculate the total capacitance. So it is you that will know this arrangement is parallel, this arrangement is series. I hope that is clear. Thank you. Now, still under electricity, we move to transformers. Here, they would ask you questions under transformers, step-up transformer and step-down transformer. I hope you remember that step-up transformers are usually used to transmit electricity to a large distance. And what's the principle for step-up transformers, they reduce current and increase, they are sent in high voltage, low current. They are sent in electricity is transmitted to a long distance in low current, high voltage. What's the reason? Because if the current is high, uh, 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 the electricity will be lost in form of heat. So here is the general formula for calculations that involve transformer. We have the voltage in secondary coil, voltage in primary coil is equal to number of turns in secondary coil all over number of turns in primary coil, which is equal to current in primary current coil all over current in secondary coil. I beg you never to forget this. Okay, one thing I would say here again that you need to know is that step down transformers are usually the transformers that are used close to our houses, that NEPA uses close to our houses. They step down the current, so they decrease the voltage and increase the current. So the kind of light we are using is the one with low voltage, high current. The kind that they send from the transmission companies, maybe like Kainji, like Kaduna, Shiroro, and others, for them to send it to our various states, they use step-up transformers. So the function of step-up transformers actually is to increase the voltage and reduce the current. So if they restore light to your houses and the light is not bright, what do you usually say? Some people will say low current. No, that's wrong English. In physics, it's not low current. It's low voltage. It's the voltage that is low, not current. Because step-down transformers usually increase the current before it reaches our house, but it reduces the voltage. So if the voltage is low, your bulb will not be bright enough. Yeah, these are just images of transformers. So inside this transformer you are seeing, something exists like this. Depending on either is a secondary or primary transformer, you are seeing the coils. The coils means the coiling of wires around the poles of the transformer. So I just put this image so that you would see in case you forgot what a transformer is. Yes, still under electricity, we talk about Fleming's rule. Very, very hot spot for JAMB. So under Fleming's rule, for motor and generator, we have left-hand rule and the right-hand rule. So the left-hand rule talks about a motor. What is a motor? A motor changes current into motion, into something moving. Just like some of our coils, they transmit the electrical energy to mechanical energy. Example, fan. A fan has a motor. As soon as you put light to it, what happens? The motor changes the electric energy it changes the electric energy to mechanical energy, something moving. So your fan moves. But when we come to generators change mechanical energy to electric energy. Example, your gen. How does it work? For it to produce electricity, something has to roll. So it is that rolling that makes it produce electricity. Contrary to a motor extracts electricity, change it into something moving. Generator, on the other hand, extract energy of something moving and change it to electricity. I hope this is very clear. Hi. Please. Just know this. I can't say more than that. Just know this. Try by all means to know this. So motor is left-handed rule. Generator is right-handed rule. Make sure you master this under rule. So when current flows through a conductor placed in magnetic field, a force acts on the conductor causing motion. So this is the left-hand rule, which is talking about a motor. Then we have the right-hand rule. When the conductor moves in a magnetic field and electric is induced. So this is what the two rules are talking about. Yeah, very hot spot. I just checked the 2025 JAMB past questions and I saw a lot of questions under specific heat capacity and expect that in 2026 too. And I will tell you why. The reason is not far-fetched. JAMB is evolving. They are now picking some key areas where they ask a lot of questions more than before. So I think I've seen up to 6 questions under this specific heat capacity, which is very good because physics has a lot of topics. So for them to dedicate 6 questions, if not more than, on one topic, know that that topic is a hotspot and you may see a lot of questions too under it. So the first thing you need to know is the quantity of heat. The quantity of heat. So you may be asked to calculate quantity of heat in different occasions. So the formula to calculate quantity of heat is mass times specific heat capacity times change in temperature. And that's the formula there. Q stands for heat. M stands for mass, C stands for specific heat capacity, delta T stands for change in temperature, the difference in temperature. So heat gain or heat loss is equal to mass and specific heat times temperature change, and that's the formula I put there. Now know the specific heat capacity of water is 4,200 joule per kg per Kelvin. This is a constant, it doesn't change. For aluminium is also given there, but no for water. You may leave for aluminium, I will forgive you on that. But for water, hey, please know, just know it. Just know it. It's not always that JAMB will give it to you. So just know it because you may need to do calculations on it. Okay, so under heat now, we are talking about Boyle's law. Never forget, I won't waste much time. I will assume you know P1 V1 equal to P2 V2. And you'll be able to do calculations under this. Now, never forget it. Always change your centimeter cube to meter cube if you are not given your parameters in meter cube. Then Charles' law, I won't also waste much time here. I know you will know this one and you know how to use the formula. In case you don't know, just let me know so that I can create a video specifically dedicated to it. Then combined gas law, general gas law, P1 V1 over T1 equal to P2 V2 over T2. I won't also talk much here. I believe you know all this. Very important under nuclear physics. Very important. I have seen questions here again and again, year after year. Please, I beg you, master this formula. Half-life. Half-life under nuclear physics, radioactivity. How do you calculate half-life? Here is the formula. The number of atoms that will remain after half-life is equal to, that n is the number of atoms that will remain, is equal to n naught, initial mass of that atom, times half raised to power n, times half raised to power n, where n is equal to T over T half. Now I'll explain everything in details. So the remaining amount that will remain after half-life, the formula you would use to calculate, because they will say if the half-life of a radioactive material is 5 years, how many atoms or how much of it will remain if 5 grams undergo 2 half-lives? Can you imagine? Or after 8 years, they may even ask you that. So you need to master this formula and how to use it. So that is the formula you are going to use. Now the problem is you need to understand n alone is the number or the mass that will remain after the half-lives or after the number of years given. N naught, that's n with the small zero down, means the initial mass, the total mass they first give you. Now, then we have, half. Then n, we need to know how to calculate that n. That n is the half-life, the time you are given of all over its half-life. Let's say they say after 8 years and the half-life is 2. So it will be 8 over 2 there. Let's calculate. Let's use this example. Now look at an example here. They say half-life is equal to 10 years. So what will remain after 30 years? So the first thing you do is to calculate your n. So to calculate our n, like I said, is equal to the number of years you are given all over the half-life. So can you see they say after 30 years and they say half-life is 10. So it will be 30 over 10, which is 3 half-lives. So our formula will now become n, that is the mass that will remain, is equal to n naught, the initial total mass they gave us, times half raised to power 3. I hope this is very clear. So this is the formula you'll be using to calculate half-life all the time. If you try to open the bracket to remove that, you are going to have n naught all over 8. But you can still use this formula perfectly well at this point. You don't need to take it to n naught all over 8 because that 3 might change. It may not be the same thing all the time. This is just an example. I hope you get this. Chai. Oh my God. I know smart students are there now writing these things carefully somewhere because they need to master them. You need to approach physics strategically because you wouldn't want to get low marks there. Alright, so we talk about alpha decay still under nuclear physics. So during radioactivity, 3 important emissions or radiations are emitted. We have alpha, beta, and gamma. So the alpha decay is usually a helium atom that is usually released. So the mass number will decrease by 4 and the atomic number will decrease by 2. If, for example, now I give you an atom with atomic number 92, mass number 104, if alpha radiation is emitted, what will the atom become? The atom will become with atomic number 90 now because it will lose 2 atomic number and mass number 100 because it was 104 before but it has lost 4. That is the alpha radiation. I hope you get this because you may also be asked like that. An atom with so mass number and so atomic number lost alpha, undergo radioactivity and lost an alpha ray. What will the atom become? So the atom will become X. That's if they did not define the atom. Then the atomic number will reduce by 2 and the mass number will reduce by 2. I hope this is very clear. So for beta decay, mass will remain the same, but charge will change. So you have +2, +1. Charge will change. So is a neutron usually converted to proton. Mass number remain unchanged. Atomic number increase by 1. This time around, atomic number increase by 1. So for gamma decays, no change in mass, no change in atomic number. It is just a release of energy. Note that. Yeah, here we come to optics now. This is the almighty formula for optics. Please master it. I beg you. You will see questions here. Know the formula for magnification. M is equal to V over U. Yes, if M is greater than 1, the image is magnified. If M is less than 1, the image is diminished. My focus will be focus on the general formula that is above. Okay, here is an example. An object distance, which is usually represented by V, is given as 20 centimeter. Focal length, which is F, 10 centimeters. Calculate the distance from the image. So we have the distance from the image, which is V now. So remember, we have U and we have V from our initial formula. So object distance is the one that is U and distance from the mirror is the one that is V. So it is just simple mathematics here. Substitute and find your V. Very simple. I just want you to be able to apply this formula because you would see questions related to it. Another important formula I've mentioned here is for magnification. V all over U. V all over U. That is the object distance, the focal length all over the distance from the mirror all over the object distance. Okay, so critical angle still under optics is sine C, which is equal to 1 over n. So light travels from denser to lesser dense medium. That's if you have total internal reflection. I just want you to know these 2 key things. If you are going to have total internal reflection, it means that light travels from a denser to a less denser medium. Do you remember glass prism? I don't know if you have used it in your school. So the angle of incidence is greater than the critical angle. So if this happens, you would have a total internal reflection. Yes, here we come into mechanics. Moment. I saw these questions too in JAMB. Yes. Moment principle. Moment of a force is a product of a force and the perpendicular distance, move in the direction of force. This is the secondary school definition that I'm remembering after how many years? Since 2012 that I graduated from secondary school. I can still remember it because I've mastered it. And anytime you give me questions, I can answer because I can remember this law. Product of force and distance, which means force times distance. That's just simple. That's a moment of a force around a fixed point. Is a product of a force and the perpendicular distance. If you like, just call it distance. Moment of a force and distance moved in the direction of force. We are going to work a question on that. So please just know that clockwise moment is equal to anti-clockwise moment. Here is an example. The weight of the girl is 300 newtons and the girl is sitting 1.5 meters away from the center. The weight of the boy is 450 newton and he's sitting 1 meter away. If you say 300 times 1.5 meter and write the number, then you say 1 times 450, you write the number will be the same. That is why it says clockwise is equal to anti-clockwise. 300 times 1.5 is 450. 450 times 1 is 450. Do you see that the clockwise is equal to anti-clockwise? That's just it. Let's work out a real life problem here, even though without image. But this says a 2 Newton force is applied 30 centimeters to the left of the pivot. Now we are given clockwise. Let's assume it is clockwise. Now, okay, I've already changed the distance to meter. Always change to meter. So we have the weight, that is the force, and we have the distance in the first direction. How much force is needed? Now look at how the question came. 10 meters, which is 0.1 meter, right to the balance. So, okay, so apply this formula. F1 times D1 is equal to F2 times D2. So what is missing here? Observe that we have F1, we have D1. We have force, 2 Newton, we have distance, 0.3 meter. Then F2, they say how much force. So F2 is not given, but distance is given, which is 0.1. Simple. So just multiply, make your F the subject of formula, and that's how you find it. So these things are very, very simple. That is to say, they may give you the weight of the girl, weight of the boy, distance of the boy from the center, and they will not give you the distance of the girl and ask you to calculate. So you are going to use this same formula and you will get it. Thank you. Yeah, so we have mechanical advantage, velocity ratio, and efficiency. You also need to master this formula. Still under mechanics. So efficiency is equal to mechanical advantage over velocity ratio times 100. Usually they will give you these parameters. All you need to do is to master the formula and know how to use it. Simple. Velocity ratio is equal to effort distance over load distance. Mechanical advantage is load over effort. Velocity ratio is the number of pulleys in case where you are using pulleys. For inclined plane, velocity ratio is length over height. Just know these small formulas, because sometimes they may not give you mechanical advantage directly, but they will give you load and they will give you effort. So it is left for you to now find mechanical advantage by saying load over effort and then put it there in your general formula for efficiency. I just hope you get me. Hi, God. These things are very, very simple, but you see people paying it. It used to make me feel. Alright, so still under mechanics, we have conservation of energy. So kinetic energy plus potential energy is equal to constant. So we know our kinetic energy to be half mv square. K is equal to half mv square, while potential energy is equal to mgh. Never forget those two formulas. That's where I would just stop on that. Then velocity and height. Okay, we have 5 more tricks to go. Okay. So this is for velocity and height. That's the speed shortcut. So if you have the velocity, you can always find, if you have your height and you have your gravitational force, you can always find velocity. This is still under mechanics and under conservation of energy. Okay, so speed is proportional to the square root of height. Yeah, still under wave, but on electronic spectrum, the order of wavelength, radio wave is greater than microwave, is greater than infrared, is greater than visible, is greater than UV, is greater than X-ray, is greater than gamma ray. Why should you know this? I have seen several questions where they will arrange them. They say, arrange the following based on the increase or decrease in their wavelength. So you need to know which one is first. Now I've given a short okay. Yes, I've given a very short way you can use to look at under exam tip so that you can memorize it and remember it fast. I say ranging Martians invaded Venus using X-ray guns. Ranging Martians invaded Venus using X-ray guns. So these are all the electromagnetic waves, the waves of the electromagnetic spectrum. So ranging stand for radio, Martian stand for microwave, invaded stand for infrared, Venus stand for visible, using stand for UV, X-ray stand for X-ray, guns stand for gamma rays. So this is in order of their decreasing wavelength. So if you can remember this short formula of ranging Martians invaded Venus using X-ray guns, then you will know it very. I'm just giving you a way to know it very well. Yeah, Ohm's law under electricity, V is equal to IR, I is equal to V over R is equal to V over I. If you just know one, what I did here is just the change of the subject of formula, and that gives me three different formulas. So please, current flows from a high to a low potential. Electricity flow from a low to a high, that's in opposite direction. So what is Ohms trying to say? He's trying to say that voltage is directly proportional to the resistance, provided that current is constant. If you can remember the law, so it's just the law. That's the formula, and it's very simple. So with this formula, you can calculate voltage, you can calculate current, and you can calculate resistance, depending on the two parameters given to you. Make the order that is not given the subject of formula and calculate it. That's exactly what I did. So still under heat, we have latent heat. Heat with no temperature change. So to calculate the latent heat, you have Q is equal to mL. That's the latent heat. This is also very simple. When temperature stops rising on heating curve, despite continued heating, that is latent heat at work. So we have latent heat of fusion, latent heat of melting, latent heat of vaporization. The goal is master this formula. Yes, the mass energy equivalence, energy stored. So we use Einstein's formula, which says E is equal to mc square. C is the speed of light. Our m is the mass. So you can change mass to energy actually. You can convert mass to energy. That's what this formula is saying. And C is a constant value here. Yeah, C is a constant value. So C square is 9 times 10 raised to the power 16. But C alone, like I said, is the speed of light, 3 times 10 raised to the power 8 meters per second. So with this formula, you can change mass to energy. Yeah, essential constants to remember. We have come to the end, right? Yes, so never forget this constant G, 10 meters per second square. Velocity of sound, 340 meters per second. 1 electron volt is equivalent to 1.6 times 10 raised to the power minus 19 joule. That's electron volt conversion. 0 Kelvin is equal to minus 273 degrees Celsius. 1 electronic charge is equal to 1.6 times 10 raised to the power minus 19. And the speed of light in a vacuum, C, is equal to 3 times 10 raised to the power 8 meters per second. Thank you. You have learned something. Like this video and drop your comments. Did you understand? I would like you to give me a feedback. If you have watched to the end, well done, you have tried. And I'm clapping for you here from my own end. If you are not part of my student and wish to be part of those students that I'm coaching on WhatsApp groups, just drop it on the comment section. Please and please like this video if I'm doing well. If I'm not doing well, just go. But if you learned something or you got something and you feel my method of teaching is impacting, as in you are understanding, just drop a like. That will help me to improve. And if I'm doing well, so I will keep doing it the way. And I won't bother if you drop an honest review. I will appreciate. If I'm fast, just say, okay, thank you, sir, but I feel you are a little bit fast. If I'm very slow, say, okay, thank you, sir, Emmanuel, but I feel you are too slow. If you can be faster in the next video. If you are not seeing the numbers or the write-up, just tell me too, I can improve. So, if you have watched this video, don't go without liking and dropping a comment. Thank you once again. Goodbye.